Okay, here's another set. And we'll just call these number 3. I think we had a number 1 already, so let's call this number 3 here. My numbering might be a little bit off, but that doesn't matter. Just make sure you know how to do them. Okay, and the next one is another find the exact value. So find the exact value of the sine. It's down a little bit here. Of, let's say, 60 plus 45 degrees. So if you see something like this, how are we going to do this? Well, if we add these up, we get 105 degrees. We can't find the sine of 105 degrees. We don't know that. That's not one of our exact values, but we know 60 and 45. So we'll break this up, and it's one of the sum formulas, very important formulas. So we know that this is equal to the sine, cosine, cosine, sine. And they have the same SIGN. And we say, remember, S and sum, or sine and sum both start with S. And then we can just put our 60 degrees, 45, 60, and 45. And what's the sine of 60 degrees? Square root of 3 over 2. What's the cosine of 45? Square root of 2 over 2. And what's the cosine of 60 degrees? 1/2. Remember, that's pi over 3. And then what's the sine of 45, which is pi over 4? Square root of 2 over 2. That's why we learned that unit circle. So if we multiply these, now remember, we're multiplying here, we're not adding. So when we multiply, it's numerator times numerator, denominator times denominator. We're not adding and putting them over a common denominator, we're multiplying. So we got the square root of 3 times the square root of 2 is the square root of 6, and 2 times 2 is 4, plus the square root of 2 over 2 times 2 is 4. I can add those up, so I get the square root of 6 plus the square root of 2 all over 4. I could call that 3a. And this would be 3b. I kind of remember these a little bit, so the last video was number 1, this would be number 3 because we gave you one before as an example when I did earlier in the day, so I called that just number 1. So we got 2 number 1s, I think, and number 3. Okay, and the next one is find the exact value, another exact value of this one, the cosine. And this would be 45 degrees minus 30 degrees. Okay. Now again, if we simplify this out, we get 15 degrees. We don't have an exact value for that, but we have exact values for 45 and 30. So we use our cosine, difference formula for cosine. Remember, cosine, cosine, sine, sine. Cosine, cosine, sine, sine, and C. Cosine starts with C, and so does change, so we change this to be a positive, change the signs, and then we put our 45 and our 30, and our 45 and our 30. And what's the cosine of 45? Good old unit circle again. Cosine of 30, 2, and the sine of 30 is 1/2. So it looks like the same answer, doesn't it? Square root of 2 times the square root of 3 is the square root of 6. Over 2 times 2 is 4. Remember, numerator times numerator, denominator times denominator, because we're multiplying, plus square root of 2 over, again, 2 times 2 is 4. And now we have a common denominator. We'll add these and put them over the common denominator, square root of 6, plus the square root of 2 over 4. Basically the same answer. Okay? And then our C problem in this little section. Pull this up a little bit. And this is where we have the tangent. And this is going to be 5 pi over 3 plus 3 pi over 4. So again, this is the tangent formula, the sum formula. So this is going to be just the tangent And it looks almost like distributing this, although it isn't. This would be the tangent of 5 pi over 3 plus the tangent of 3 pi over 4, all divided by 1, and this is minus the opposite sign here, minus, and then just the product of the tangent of 5 pi over 3 times the tangent of 3 pi over 4. I have to use our quadrants here and be careful. This is pi. Okay, so what's the tangent of 5 pi over 3? Well, the tangent of pi over 3 is what? That's the square root of 3. But what quadrant am I in? Well, it looks like I'm in the fourth quadrant, so that's going to be negative. So negative the square root of 3. Plus, and what's the tangent of 3 pi over 4? Well, the tangent of pi over 4 is 1, but it looks like I'm going to be in the second quadrant, so it's going to be negative 1. And then I just multiply these. 5 pi over 3 times 3 pi over 4. So if I did my work correct up here, and a negative times a negative is positive, so that's just the square root of 3. And we could simplify this a little bit. You could take out the minus sign, and you could have the negative, and you could have the square root of 3 plus 1, all over 1 minus the square root of 3. Then you could multiply this minus down times the denominator and make this a negative and that a positive. Look a little bit neater. The square root of 3 plus 1. And this would make this positive, the square root of 3 minus 1. So that's a nice, neat answer. But any of these would be acceptable. And remember, you don't have to rationalize on this. Just leave them like this. That'd be fine. Okay?